Hi there and welcome to AS Level Physics with me, Will Kulwicki. Today we're going to be looking at a chapter on atoms, nuclei and radiation, focusing on the alpha particle scattering experiment. Okay, let's jump right into it. Now, the alpha particle scattering experiment was a very significant experiment in physics conducted at the beginning of the 20th century by Ernst Rutherford and his colleagues Geiger and Marsden. At the time, physicists believed that the atom was like a plum pudding. Now, what is? Well, here's a plum pudding, and as you can see, it's a sponge base with atoms embedded into it. And they thought the atom was similar to this. They thought the sponge base represented positive charge, which was uniformly distributed throughout the atom, and the negative charge was embedded within that positive charge, something like this. Now, this is important to know because Rutherford's alpha particle scattering experiment actually showed that this model of the atom was incorrect. And let's talk particle scattering experiment to find out why. Okay, here we have a diagram of the alpha particle scattering experiment. On the left-hand side, you can see that there is a source of alpha particles, and this was directed at a thin sheet of gold foil. An alpha particle is a helium nucleus with a nucleon number 4 and a charge of +2e. A gold nucleus the gold atom has a nucleon number of 197 and a charge of +79. So we can see that the helium nucleus is a lot smaller in comparison to a gold atom. What was expected was that when they fired this beam of alpha particles, because they believed in the plum pudding model where the charge was thinly spread, there would be little or no deflection and the helium nucleus would pass straight through. What was observed, however, was particles underwent a different range of deflections. Most went straight through, however, some were deflected at varying angles less than 90 degrees, and very few, about 1 in 8, were deflected with angles larger than 90 degrees. They were backscattered. So this showed that it can't be a uniform charge throughout the atom, and this led Rutherford to redesign the concept of the atom. Okay, alpha particle scattering experiment key features. We know that alpha particle is a helium nucleus with 2 protons, 2 neutrons and no electrons, and has a charge of +2e. This is important when we're trying to figure out what's going to happen when it approaches a gold atom. Before alpha particle scattering experiment, physicists believed the atom was like a plum pudding. That meant the positive charge was spread out all the way through the atom, and the negative charges were embedded in there like plums. So what they did was they fired alpha particles, these 2 protons essentially, and 2 neutrons, at a thin sheet of gold foil. Most of the alpha particles passed straight through. 1 in 8,000 were deflected backwards with an angle t degrees, and some were also deflected with an angle less than 90 degrees. So this told us that the positive charge of the atom must be concentrated at the center in order to cause that great deflection. So we now think of the atom in a different way, and we don't think of it as being like a plum pudding. We think of it more of being with a nucleus at the center and then electrons circling around the outside. Okay, let's take a look at a couple of questions now from the textbook. Pause the video and see if you can answer these. Okay. Okay, number 1, Rutherford scattering experiments were done in an evacuated container. Explain why this is necessary. Well, as we just mentioned, this is to prevent the alpha particles being deflected by air molecules and such in the air. Question 2. In Rutherford's experiment, alpha particles were directed at thin gold foil. A small fraction of the alpha particles were backscattered through 180 degrees. Describe and explain how the fractured changes if each of the following changes are separately made. A. A thicker foil is used. A thicker foil, well, that would increase the number of alpha particles that were backscattered because there would be more atoms of gold foil, more chance of an alpha particle hitting a gold atom, and hence being backscattered. B, if faster alpha particles were used, well, if faster alpha particles were used, there'd be less backscattered because the inertia of the atoms would tend to carry them forwards more. C, if a silver foil is used, a silver nucleus has less positive charge than a gold nucleus. Well, there would also be less backscattered because there would be less charge, which means less deflection